My name is Jacob Wall, and I'm a graduate engineering student at the University of Idaho. And I've been researching this hydrogen boosting, water fuel, all these things for about 4 years. And it's pretty interesting, and what this presentation will be is kind of my journal review, so to speak, of the kind of the peer-reviewed technical journals that have to do with this technology. So, go ahead and start. Okay, the first thing I'm going to look at is what does hydrogen do in an engine? The first thing it does is it decreases emissions. The main emissions are carbon monoxide, nitric oxide, and unburned hydrocarbons. Also, hydrogen increases the performance, and in this area would be the fuel economy and the power. The first study I'm going to look at is, this study was actually somewhat negative about using onboard electrolysis. So I'm just kind of using this as an example of the disconnect between the quote theoretical studies and the actual experiments in the car. In this study, they did a computer simulation, and they found that 10% hydrogen and oxygen mix had about the same effect as adding 20% hydrogen alone. This is where I think they ran into the problems and why they weren't really seeing the kind of performance that they should see. Is to simulate electrolysis gas, they mixed 97% air in a tank and then 2% hydrogen and 1% oxygen, and then they claimed that this would simulate electrolysis gas. And so basically the reason they did that was they were worried about compressing it, and so they were trying to get the hydrogen below the flammability limit. And just starting off right there, that they kind of defeat the purpose by being below the flammability limit. And so that was basically that study. Okay, so here's the electrolysis unit they were using for their assumptions were a unit that produced about 402 milliliters per minute of hydrogen at 169 watts. So this cell would be of MMW rating, which is milliliters per minute per watt, of about 2.37. Now, I built a small SMAC booster, and I'm sure a lot of you guys have. And that one typically gets around 4. So this cell that they're using for their assumptions saying it doesn't work is, quite a bit. It's not really representative to hydrogen boosters that we've been using. This next study is an actual experimental study in cars, and it's done by a university in Turkey. And they used a basic single cell unit, and they were producing about 333 milliliters per minute at about 270 watts, and that comes out to be only an MMW rating of only 1.23. But they tested this on 4 vehicles, and they found that the emissions were reduced by about 50%, and then this chart shows the 4 different vehicles that they used and the fuel economy increase that they were able to achieve. The next section I'm going to talk about is emissions. Carbon monoxide is a product of incomplete combustion, and it typically occurs in rich mixtures. Unburnt hydrocarbons are also a product of incomplete combustion. Inside a cylinder, you have, when the fuel's burning, you have the piston coming up, and then the walls of the cylinder are metal. And so when you have that fuel start to burn, especially if it burns slow, there's a lot of time for the heat to transfer out the cylinder walls, and that causes a loss. And also there's a section of fuel around the cylinder that won't burn because of this effect. Also, there's a gap between the piston and the cylinder, and this is also an area where unburnt hydrocarbons can be created. Nitric oxide. Now this is something that when you're adding hydrogen, it can cause problems because since hydrogen burns faster and hotter, if you don't adjust the timing, you can have increased nitric oxide emissions. So this chart is from another paper where they show, first this chart shows the emissions without hydrogen, and this is the air to fuel ratio, and then the different emission curves on this axis is the CO emissions, and then this is the hydrocarbon, and this is the NOx. And then the other chart is how they're able to clean out the mixture and also have reduction in those different emissions. So basically, the reason why the carbon monoxide is reduced is because the hydrogen is able to burn a lot faster, and you have a more complete burn of the hydrocarbon fuel. So that's what allows the CO to be reduced, and for the same reasons unburnt hydrocarbons are reduced. Also, if the the timing is adjusted correctly and it's tuned for a hydrogen and gasoline mixture, then you can also reduce the nitric oxide emissions. So in summary, adding hydrogen to a fuel, to a gasoline fuel or diesel fuel, can reduce the emissions. There seems to be a big disconnect between the theoretical studies that have been done and the experimental. So there needs to be a more detailed study using actual units and vehicles and not just using simulations. And so then I'm a student at the U of I, and so I'm planning on doing a research project, and I've applied for a grant through the Idaho Sustainability Initiative. And we are going to put a hydrogen booster in a university vehicle, and we're going to test and monitor the fuel mileage, the emissions, and we're also going to try to put the vehicle on a dyno and get it tuned properly. And this test vehicle will be a 1990 Chevy pickup truck.